All right. So we know what is an object. We know what is a class. We know what is a value type. We know what is a reference type. So now I will talk about something. Today, we will really go into object-oriented concepts. Okay. So everyone knows when you create an object, there is a pointer pointing to the object. In that object, there is something, right? So, for example, see, I will create a car class, public class car. I will create a car class like public int something. What do you say? Year, public string, make, public. Say that again. Win number, yes, okay, yes, perfect. So this is a car. So if you see in, like when someone says car C is equal to new car, you see the new see the object, you see an object. So what is the pointer? C is the pointer pointing to the object. So C is the pointer pointing to the object. What does that object contain? So if you create 10 cars, 10 objects are there. Every car has year, make and win. Got it? So if you say that let's say I created a class, okay, and you can create, for example, let's say public void register with the DMV. Okay, all right. So there is a method and public void. What is the last one called? Total, right? Total it. Okay, all right. So this is the methods. For example, if you create a car, every car you can create 100 cars. 100 cars will have their own make, their own year, their own VIN number, and on each car you can call registration, right? So the registration on one object cannot be the same as registration of another object, right? So every car registration is different, every car's VIN number is different, every car's year and make are different too. That is called instances. These are called instances, and these are called instance methods, instance variables, because they go on to each object, and these are called instance methods. Got it? They are called instance method. Now, for example, when you see a car, now someone will write. So whenever you see an object, how you are visioning, for example, you will see this one and you will see this one, and see there is a car like 1, 2, 3. For example, a car has an engine too. For example, someone will write a class of engine, public class engine. And what does this have? For example, number of cylinders, public int number of cylinders, horsepower, right? Public double, is it double? Horsepower, something like this. Okay, so this is about an engine, that is about a car. There are two different classes. How will you tell that a car has an engine? Now you'll go here and you'll put it saying that public engine. A car has an engine. This is called composition. Before it used to be compositions of only value types, but it can be now there will be a pointer, and this pointer is pointing to this engine. So you are telling that car has an engine, but that does not mean it should sit inside the object. It is a link to object. The link is inside that. Yeah. Yes, generally we use private. See, I am giving public to see others, but generally it will be private. Variables are always private. Variables are 90% of the time. So this is called composition. So when you see an object inside another object inside another object, the object is not there in another object. The pointer of other object will be there. So that is the reason. So when you say, for example, who created int? Someone else created int. Someone else created string. I created engine. I put it in the car. Car is part of a number for, one number, two strings and one engine which I created. Got it? So you can create an engine and you can put this engine. So it's all about, this is called composition. Okay. This is called composition. So objects are compositions. Arrays are collections. Got it? Array is also an object. Array is a composition of collection. Okay. Alright, let's not worry about that. Okay. Now, so we know what is pass by value, pass by value, right? In Java, there is no pass by reference. There is only pass by value. In Java, there is no pass by reference. So there is only pass by value. When you pass a value type by pass by value, you copy the value and send it. So if the callee method changes the value, caller will not be affected. I have a int I passed it to this guy, he can change it to 10, 20, I don't care, I am still 10 only here. Okay? But when you pass a reference type by value, you are passing the reference, you are not really passing the object. You are copying the reference, you are not copying the object. So you copy the reference, so it is pointing to the same object, they can change the object. They can change the object. So when they change the object, you will be affected. But when they remove the pointer to the object, you will not be affected. Okay. So they can use the same pointer to change you. That is called pass by value of a reference type. So in Java, there is no pass by reference. So this is the most famous question. Okay. And in some other languages like PLSQL and other thing, when you pass this object, they copy the object also. They copy the object so that, they have their own object, they have their own object too. That's why in PLSQL there is a keyword called no copy. People write no copy in front of it. Please don't copy the object. Okay. So that means pass by value of the reference type there. Okay. So in most of the languages it is the same, but Java says it in a different way. Okay. When you pass a value type, it's passed by value. When you pass a reference type, the reference is passed by value. Okay. All right.
So last class, what you showed, it's not passed by reference.
It's not passed. There is no pass by reference. It is passed by value, but we are passing the reference as the value. In Java, there is no pass by reference at all. I am passing a reference type by value. There are two types, value types. When you pass a value type, it goes, value is copied. When you pass a reference type, reference is copied, right? Means that is passing by value. We are copying something. Yes, passed by value of reference. You are passing the value of reference. You are making the copy of the reference value. So that is passed by value only. So there is no pass by reference at all. It's all passed by value. Okay.
So when you're passing reference, what do you call it? Passed by
Value only
by reference. No.
of a reference type. What are you passing? You are passing a car. That is a reference type. So you are copying the address. Or if you are passing an integer, you are copying the value. Agreed? Yeah. Now the actual fun starts. So today we will be really doing some good things, good examples too. Okay. All right. So as I mentioned, there are two kinds of variables. So first variable is instance variable. What is an instance variable? For example, let's see. There is a student. There are 3 instance variables. Do you see that? There are 3 instance variables. So for example, you can write a method here. You can write a method, for example, public, let's say, set student name. Okay. Alright. So public void set student name, and you will pass string name. Student name is equal to name. Got it? So what is this variable called? What type of variable it is called? Instance that belongs to the object. So when someone creates a student, they get a student name. Means every instant has it, right? For example, when you are defining a laptop will have ABCD keys. Means that ABCD keys will be there for every laptop, right? So that is an instance variable. Got it? So an instance variable is something goes on to every instance. Then there are other kinds of variables called local variables. Local variables only belong to the method. Local variables. Variables declared inside a method are called local variables. Got it? Their scope is only between that method. They can't see outside the method. They are not accessible outside the method. For example, if I do int I here, int I is equal to 10, where did I define I? Inside the method. For example, if I have some other method tomorrow, like let's say public void set student ID. Okay, and I will put int ID. This is a different method, right? This is a ID is a see here. Let's say int I is written inside this method. So can I access the int I here? I equal to 50. Can I do that? No, because the variable belongs to one method, cannot be accessed another. But I can use student ID everywhere. Because student ID does not belong to the method, it belongs to the object. It belongs to the object, see. And remember, another thing, when will be the object created? When will be this variable will be created? Can anyone tell me when is this variable created in the memory? When you create an object, when you say new, you are getting that new student name there. When will be this I will be created? When you call that method, no, it won't be created by static. When you call that method for the first time, so when you say, let's say, so for example, when I say student S is equal to new student, when I did this, automatically student name, student ID, and what else is there? Student type is created. So there are three variables created. And what is the value of student ID? 0. What is the value of student name? None. Perfect. So object is created there inside that. Is int I created? No, int I is not created. Int I will be created when you say s dot set student name, and if you pass something like s or something, when I call this method, when the method is called, it will come here. That is called what is that? Yes, you should always say you are calling a method. That is you cannot say any other thing, right? I am calling the method, yes. S dot set. You are asking it to run. When you execute, you are executing that method. You are asking for that functionality. See, in real world, if you need something, you'll go and ask something, or you'll go and do something, right? For example, if you need to transfer me money, what will you do? You'll go and log in and you'll click that button. You're doing. Here in program, to do something, one needs to call another. That is called calling. Simple. We call method calling. Okay. So packages are part, methods are part of objects. See, that is the thing. In procedural language, people used to write methods. In object-oriented programming language, methods are part of the object. So you need to create the object on the method you call, on the object you call the method. Before, for example, to call the deposit, you need to have account. You are calling the deposit on the account. You are calling the set student name on the student. So there needs to be an object. So you will create the object and you will then execute that method. So see, for example, if I want to change the student ID, what will you do? S dot student ID equal to 101. But you can't change like that. Stuff is all about methods. You cannot directly access everything and change it. You cannot change your account balance. You need to do operations. Operations are nothing but methods. So you call the methods like set student name s dot for this student. I'm telling that make the student name is equal to okay, that one. So when I call this method, it will come here. It will come here. Means generally a method executes in its own stack, separate stack. So at that time, any variables declared inside that method will be created. Once the call is done, when it comes to the semicolon, the call is done, the logic is done, all the variables in that method will be deleted. They are called temporary variables because they are created for logic. For example, when you are doing a for loop, you put a int I counter. That is for logic only. There is no business purpose. You are not doing any business with it. So any variables which are created inside the method are called temporary. We are only doing that for the logic to happen, for nothing else. So they are called temporary variables. They are created when the method is called. And deleted when the method is exited. Okay, all right. Yes, same. They are different names. So local variables are also called temporary variables. They are also called stack variables. Okay, it's okay, leave it. Yeah, let's not go deep into that. So is this the only local variable which is created? Is this the only local variable which is created here? Is there any other? Even these parameters are also local variables. Parameters are variables inside that method memory, but someone else will put the value there. Okay. Parameters are also, see this method, for example, when you call the set student name, automatically, see, for a method to run, when you call the set student name, let's say, Sam or something, okay, automatically a memory will be created. It will go and see how many local variables are there, name and I. So it will create two variables, name and I. And what are you passing into name? This one. So it will, it will put Sam into this one. And what did you do? I equal to 10. It will do I equal to 10. And this will be done when this execution is done. When this execution is done, it will be deleted. So how many times you call a method, that many times the variables are created. If you call this method for 100 times, 100 times the variables are created, 100 times the variables are deleted. That is called method. So any variable declared inside this one is for that method. For example, if I do int I is equal to 20 here, is this I and the above I are same? No, they are different. They belong to two different methods and they are nowhere related. Because you can't call two methods in one. That is a different method, this is different method. That is different logic, this is different logic. Okay? Alright. So for example, so now this, and so when you write an instance variable, in which memory it is going? Heap. It is going into heap memory into an object. It is going into an object and object goes into heap. When you write a variable inside the method, in which memory it is going? Stack. It runs on its own stack, method stack, separate stack. So, for example, if I have a student name on the top right, this student name is there, right? Student name is there. Can I write the same, this one also student name? See, anyway, when I define something inside the method, it is in stack. This is in stack. This is in heap. This is in heap. So they are two different. They are two different, right? They are two different. So, can I have same name? I can. Because that is somewhere else, this is somewhere else. So I will write student name is equal to student name. Which student name is equal to which student name? See, why to write name? Why can't I write full name, student name? Why do I need shortcut there? Say it again. Because it will confuse people. But they are in different memory. You are allowed to have same name. Because when someone is passing student name, you should call it student name only. When you are assigning the student name on object, you have to call it. See, you have to speak the business. Then how will you do it? Then how do you know? There is a keyword called this keyword. This. All the objects will be called this. Means my objects. This is this student name. This is this student name. Got it? Similarly, and another thing I want to tell you, if you write a local variable, if you write like int I and you are not putting it, if you are not initializing, it will fail. Instance variables will get default values. Local variables will never get default values. You have to initialize before you use, otherwise there will be a compile time error. Okay, local variables should be initialized before usage, otherwise compile time error. I did not understand, Ramani. Okay, 1 second. You raised your hand. Yeah, Ramani, speak 1 second. Yeah, speak up.
Yeah, you said like a new student is equal to new student in that method, you said.
Oh yeah, that S is in the, if I, in this method,
Right.
if I do, again, very good. In a method, if I do that, S is still in stack, right? Student, always when you say new something, that is always in the heap only. But that S belongs to that method stack. For example, here, we do again student S is equal to new student. We can do that. Got it? Okay. When you are doing this S is created where? Inside this method.
Yeah.
After this method, this S will be deleted. That is garbage again.
I mean to say in the set student name, when you said like the student name, because there are like one is in the heap and one is in the stack, right? And you put it in the inside that method set student name. So I mean to say that set student name, the first one is equal to the student name is equal to student name you gave before. Remember? So I was like asking. So the student name in the what do you call?
Heap is equal to student name in the stack. That's what you are telling. Am I right?
Oh yeah.
Yeah. All right. So
Which one gets what? Which? That's what I was asking.
so okay. Now you know that, right? We cannot just leave it like that. You have to use this keyword. Okay.
Yeah.
All right.
This, yeah.
Yeah. So now I will tell you what is this actually. See, what does this mean? See, you have generally a program. This is the main method. The main method, the program started here. Okay, just like that. What did you do? You said S. You created S here, and you created a object here. You created an object here, and you pointed to this one, right? And then what did you do? On S, you are calling a method. Every method runs in separate memory. Every method runs in separate memory. So this is this method memory. But where is this method? On this object you are calling. On which object you are calling? You are calling the student name on S object. So onto every instance method, this S will be copied. S will be copied. This pointer is called this. Got it? For example, see, I will tell you a simple example. You got a Honda car, to 2013 Honda car, and I got a Honda car. We get manuals. You say that this car has, dock somewhere, and if you want to open the trunk, you have to go and click this one. Even for you also, it will say that this car has the same thing, if you want to open the trunk. This is a definition. But when I am implementing this is my car, when you are doing it, you are doing with your car. Understood? So when I read the manual and go and do with my car, I am doing it with my car. When you are doing it with, you are doing with your car. Agree? You understood what is this? Okay. So this is, for example, you are currently doing on this student. Right? On this student, you are doing something. On this student, you are doing something. That this will be copied into that method, into that doing. Okay. So which object you are working currently is this. Which object you are currently working is this. Because you are calling the method on S. You are calling the method on S. For example, I will tell you one thing. When we this is simple, when you are doing things like, you wake up morning, you have to start your coffee, you have to do some other thing. You'll forget when you are going into methods. You are the object. You are the object. You are going into many methods. You forget who you are. You have to remember back using a pointer always. Got it? You have to, on whom you are doing it. If you are doing this for 5 people, you'll forget on whom you are doing it. Right? For example, if you are doing the job for your 5 kids or something, you'll forget to whom is what. So you need to put a reference like this is for that person. Because on which object you are working. That is this. So this is always a pointer. So when you work on when you call the instance method on any object, a pointer is copied onto the that method's memory. That is called this. So when you say this dot student name, you are calling student name. When you create a student name here, that is student name here. Now S is copied into this method's memory as this. So that is, this is pointing to the object. Agreed? So here when you say this dot student name, it's object student name. When you say other student name, that is inside the memory which is created. So when you say this dot student name, it is this student name. Agreed? Am I clear here? So anytime when you say this means that is current object. This means current object. Okay? Alright, now I will write an example. You will tell me Okay. I will. Yes, yes, I will show it to you.
Is any particular reason you are creating the pointer and calling the method in a separate job?
I can do it in the same thing because I don't like personally to run it from the same time. You can write the static
I asked
method.
the same question today.
Okay.
Yeah, to Shilpi. She said, solve this. I mean, the encapsulation, right? I mean,
Yeah,
write
because
the method in one class and
yeah,
call it from
as long static is different. Always when you write static, it's different. It has nothing to do with that class. Means it has nothing to do with the object. When you write static, I will come to static. Okay, that is the beauty of static. So let's come back later. Okay, but many books will do it in the same place. That is the problem. Yes, but generally when you write something, you don't run it from there. Definition is different, run is different. Okay, so see this one. So read this class please for me. How many instance variables are there? I am not, don't ask me questions. I already asked one. So how many instance variables are there? I did not ask local variables, right? Instance is always one. Okay. So your question is irrelevant. Okay. So how many instance variables? Only one. So only one. This is instance. Everything else is in method. Those are local. So for the first method, do something method, how many local variables are there? What are there? For the second method, do some other thing. How many local variables are there? One. What is that? I. So the I on the top is different from the I and J. I in the second one means I in the first method. I on the top one is different from the I in the second method. Is I from one method is different to I from another method? Okay. So now when I create an object, which I is getting created? Instance 1. Instance 1. What is the value of that I when I created this object? 0. Yes, it's 0. The first one, it's a default value 0. Agreed? Now I am calling the first this do something method. Now sc.I, you know that, right? sc.I was 0 before I called this method. Got it? Now I am calling this method. I am calling this method. Now tell me what will be I. This I. Which I am I asking? I am calling this method, but which I result I am interested in? sc.I. Which I? When I say sc.I, point me that I here. Point me that I here. Yes, I am calling this method. See, I am calling this method and I am asking you to print sc.I. When I say sc.I, is it the instance variable or local variable? This sc.I. Yes, instance variable. This I am interested in. Yeah. Now when I call this method, tell me what happens to this. It changes to this dot I will be 25. Say it again. Tell me at this point, what is the value of the sc.I? It won't be 0 because I am calling the method. Yeah. I am calling and it will become one is partially correct, not say it again. 55. No. 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 And 35 is also not correct answer. It's 20.
10.
No, it's 20. You're passing 10 and I'll tell you one thing. So when you came here, when you came, when I print this one, what is the value? 0. Then I call this method. Inside this method, what happened? A IV is created inside that and J is created. And this dot I, okay, is equal to what? 10 plus 15 plus 0. What is the value? So now this SC dot I became 25. But did this method stop here? This method is calling another method. This method is calling another method. And what am I passing? 10. I passed 10. And 10 plus 10 is equal to how much? 20. I put 35. Then I erased it and I put 20 again. Got it?
But you are not calling
Do some other thing. But that method is calling.
that object, right?
No. Where is that method on the same object? This guy is calling me the other method for the same object.
The last line we process.
Yeah.
We call it.
See, even though I am not calling, but the method is calling me for it.
But then this dot I will be it will be there for do something, right? I mean, once you put the value.
Yes. Yeah. See, where is this do some other thing?
It's in that.
In which class is it in?
It's in
Scope example method only. Am I calling using scope example object only? Am I calling this one using scope example object only? So my object will always go there. My object will always go there.
So even if you are not calling that do some other thing, you are calling with 10, right?
Yes, that this will be passed will be here. Yes, as long as I'm the same type of object. Yes, it is 20. Okay, let's see if it really prints 20. You still don't believe me, right? Okay, all right. Now you understand. So object it's not about. So this dot I is the what we are interested in. So now you understood what is the difference between a local variable and a instance variable. Okay. All right. So I will tell you. So this reference is very useful. Okay. This is one thing, and the scope means if you create a local variable, the scope of the variable is inside the method only. The object scope is everywhere. Object's variable scope is everywhere. That is what scope means. Okay. So now that is called scope. So this is a pointer to current object. Scope.
That means SC dot I and this dot I, it will be same throughout the, how many methods you are calling, it will be same throughout that.
Yeah. For example, let's say, so now for example, what is the other purpose? What is the use of this keyword? Tell me. This is the pointer to the current object. Okay. There is one more thing. In do something, you want to call, for example, see, you want to call in student there is a method. Let's say there is somewhere else. See, I'm writing some other thing. Public static void do nothing. Okay, and it will take a type of scope example. It takes a parameter. You can pass any scope example, and it will say, okay, c dot I equal to 0. Now you are here. You want to pass the object to that one. You want to call whoever is. So scope example dot scope example dot Where did I write this method?
In test you wrote this.
In test I wrote it. Where did I write that?
Just do nothing.
Do nothing. Where is this keyword here? This can't be this here. If you see, if I am reading a Honda manual, Honda will become this. If I am reading BMW manual and I can't do the operations on Honda. You understood, right? You got it? Yeah. It's scope example tested or do nothing. Okay. If there is a method which takes someone, for example, you are passing this to some other person and they take a parameter of your type. If they take a parameter of your type, for example, see you are working with an account and you want to pass this account for auditing. Audit method takes what? Account. So you will pass this means, for example, on every, let's say tomorrow, there is a audit method which takes account. But audit, we don't call auditing separately. On every transaction, on every deposit into the account, we run the audit automatically. Understood? For example, on every deposit, your customer is creating an account object and he is calling the deposit. But automatically we have to pass this account to audit. How will you pass inside the deposit method? This keyword. Pass it to the audit method. Understood? You pass this keyword, you can use, if you want the scope example object to be passed to another on this method, then you will use this keyword. Yes, I can run this program, not a problem. Finally, it will be 0. When you now do this, it will print 0, 0. Because of, yeah, it will. If you, for example, you are in a method, you need extra functionality and you need to pass this object to someone else. How will you pass it? This keyword. Your object will become this. Okay. This represents current object. Whoever is calling this do other something is going into that. Agreed? Is going into that. Okay. Alright. So this will be used to pass the current object to other methods too. Okay. Alright, enough of this scope. So now you but the basic thing is, did you understand the difference between local variables and instance variables? Okay. So now I will tell you one more concept. Okay. Is this an object? Array an object? Where is this object? Where is this object? Heap. Okay. Is this a pointer? Where is this pointer? Because we started just the program and we are still in stack. We are not in part of an object or anything. We are part of stack. Now I created int I is equal to 10. Got it? Where is this I? Stack. Okay, because that is a value type and we are in stack. Now for example, I will say array of 0 means first element, right, is equal to I. So where is this I? Where is the I? Stack. I is on stack. Where is the array box? Heap. So you are taking from the stack and you are putting it in the heap. Fine. If you are doing this for a million times, will there be a performance problem? Because you are moving from one memory to another memory and one memory to another memory. right? Yes, if I put it in a loop and if this is running for 1000 times, it will be problem. Why not put the integer also in there only, heap only? But integer is not an object to go there. Why can't we make objects? Because there is no class like integer class. Why can't we create one class? Those classes, so Java created classes for every value type. Those are called wrapper classes. So those are called wrapper classes. Java created classes for all the value types like integer, classes for all value types. Got it? Like, yes, integer, like character, capital, and boolean. See, these are the classes. For example, now I will create an integer object. So if you see integer, my int is equal to new integer. You see this? And I am passing this I into there. I am passing this I into there. Agree? I am passing this I. So where is that new integer? Heap. Agreed? I am passing that I in there. So when you take a value type and put it in a box and put it in the heap, that is called auto boxing. You are boxing it, right? You are making a box for it and putting in the box. Before it used to be directly value, now you are putting it in a box. That is why it is called boxing. Agreed? Boxing is not the real boxing. Okay. So this is called auto boxing. Now, so how will you do this? Let's say my int dot int value. So you are taking the integer value of that object. So you are doing heap to heap operations. Okay. This is called boxing, auto boxing. Creating objects for value types. Agreed? That is called auto boxing. Right? Now next. When you take out from the box and put it into the regular value type, what is that called? Unboxing. So when you take out from an object and put it into a value type, that is called unboxing. Okay. Alright, so enough of all these small topics. Let's come to the core of object-oriented programming. That is nothing but inheritance and polymorphism. These two things will make it object-oriented programming object-oriented. They might look simple in concept. Concept-wise, I can't really teach you much. But when you go and work tomorrow, you'll find the real usage of it. So if you want a 5-minute break, I can give you, because this will be a long class. I'll complete this chapter for sure today. Okay, so take a break for 5 minutes. Yeah. Why should we write classes? Just because everyone is writing Java class, we should write class? No. First one is encapsulation. The first thing is encapsulation. You are putting together. You're putting together. So when you get an object, you get everything. And on that object, you call methods. That is called encapsulation. So when you are putting together, and you can hide the data and you can expose the behavior. So encapsulation, right? So putting together, seeing it as an one entity. Seeing something as one entity is first thing. So encapsulation is the key. Then the next thing is inheritance and polymorphism. I'm not saying inheritance separately, I'm not saying polymorphism separately, I'm saying inheritance and polymorphism because they go together. They really go together, they can't be separate. One gives other, other takes from another. Okay, so let's see what is this inheritance. Okay, both are separate, but in Java one comes through other. One comes through other. So let's say I am writing two different classes actually. Okay, let's say employee is there. Tell me attributes for employee. Public int employee ID, employee name, public string employee name, public string is string. Perfect, very good. Anything else? Okay, department and other things we'll take care of later. Okay, because departments is a entity, not a, means you have to create another class and put department pointer here. Yeah, department class here, like you should put like, you know, like this, and department like this. Yes, very good. Department is another. Now you understood foreign key, primary key here. How am I pointing? Pointer is the one who is pointing to another object of this. Okay, so now this is the one. So tell me some method on this one. Say it again. It will add to database. I don't want to write the program to add it to database now. Now let's say get details. Okay. For now, return. It will give you nice details like, you know, your employee ID. Okay. Okay. Plus employee ID. Employee name. Okay. Okay. So when someone really calls get details, what happens? They will see everything. For example, right now, let's say I will employee is equal to new employee. So employee has the ID, name and salary, right? So if you say sysout e dot get details, it will print 0 null 0.0. This is this. Okay. 0 null 0.0. So this is fine. Is manager an employee? Is director an employee? Is supervisor an employee? Is CEO an employee? Is CTO an employee? Okay, everyone is an employee. So let's say for we are writing manager. Manager is a separate entity. So we will write manager. So how we will do is like we will write manager class. Manager. Okay. And manager will also have employee. He will have everything, right? He will have everything here. He will have everything here. But what else manager will have? Manager is managing a department. So he will have the department ID or something. Okay. Employee is part of the employee department, but means he might be an employee. So we are not talking about that here. So he is managing a department. So what we will have? We will have the department ID or something. Okay, department ID, which he is managing. Okay. So for him, we need to print the department also. Am I right? So we can't just leave it like that. So department ID. Got it? Agreed? If you see, manager has everything same except that one thing. Director has everything same except one thing, because manager is an employee. There is employee inside the manager. If you see, if you remove this one, it's nothing but an employee, right? So in Java, you should not, means there is a concept of inheritance. You should not duplicate it everywhere. You should take it from using inheritance. Means instead of writing all this, what we will do is, we will say extends employee. Means you are telling that manager is a child of an employee. Employee is the parent of manager. So manager is getting everything from the employee, and manager is called superclass and employee is called child class, subclass. Perfect. Okay, subclass. So let me write this. So inheritance is implemented using extends keyword between class. Okay, a class can extend another class. Parent class is called superclass. Here parent is super, not child. Okay, child class is called subclass. Subclass will inherit, means get everything from the, inherit everything from superclass except anything private. If you write private, that is only for except private and constructors. Subclass will inherit everything from superclass except private and constructors. Okay. So now does manager has employee ID? Okay, let's go and find it. You'll create manager object. Manager m is equal to new manager. M dot employee ID, he has it. M dot employee name, he has it. M dot salary, he has it. M dot department ID, he has it. So that is called inheritance. You inherited everything. So when you say sysout dot m dot get details, yes, okay, we are calling the get details of manager. Okay, all right. So, all right. Okay. So this is called inheritance. Means the manager is getting employee ID, employee name, and salary from employee table. Sorry, employee class. Okay. This is called. This is done using extend. So if I write employee ID private, will it come there? It won't come there. This is called inheritance. So inheritance will give everything to the child class. In Java, there is only called single inheritance is there. In Java, there is single inheritance only. What is single inheritance? You can, a child class should come from only one direct class. It can have class above that too. Means there can be grandparent and everything. But there should be only one direct parent. So a class can inherit from only one superclass. So a subclass should have only one superclass. Okay. In C++, there is multiple inheritance using classes. So in C++, there is a common problem called a diamond problem. Find it out. What is this diamond problem? After this class, there is something called diamond problem. Okay. No, default is default. It will come there. Default is not. If I don't right now, as you, I think next slide is that only. You are asking me just at the time. See? Yeah. Okay. These public private are all called access modifier. They are not scope. They are where it can be accessed. That is called access modifiers. Okay. What is an access modifier? For example, it can be public, it can be private, it can be protected, it can be default. Okay. These are the four things. Public means it's public everywhere. So a class can be public, a variable can be public, a method can be public. Agree? That class, if I don't write this class public, let's say if I don't write this class public, I can means what I mean is like I can write this class public or not. Okay. Alright. Similarly, I can write a variable public or not, or I can make a method public or not. Okay. I will come back. Private means inside class only. Inside class only. For example, if I write this private, this is only accessed within the class. If I write this private, this is only accessed within the class. What did I just do? Yeah. So if I write this private, it is only accessed within the class. Okay. No one outsider cannot see it. So will not even child also. Private is private. Right? Private is private. So not even subclasses. So can a class be private? If private means, so if I can write a variable private, I can write a method private. Can I write a class private? Private is inside class. Is class inside another class? No, a class will not be inside another class. So you don't write class private, but you can write. That is called inner classes. When you have a class, really if you are writing another class here, class, public class like employee, let's say address, then you can write this private. If a class is sitting inside another class only, you can do it, but no one will write inner classes. Inner classes are bad. Inner classes no developer is writing nowadays, so you won't see private class. Okay. So generally private is only for variables and methods. Agree? Because they are inside class. Then there is default. Default means inside package only. Anyone within the package will see it. For example, if I don't write this int employee ID, can my child see it? Manager see it? As long as he is in the same package. Can another class inside the package see it? Yes. Only inside the package. If I remove this class public here, remember class default, only classes inside my package can see it. Outside classes will never, outside packages will never know there is an employee class. Okay? So that is called default. Default is nothing but inside package only. Okay. Then there is something called protected. Protected is inside package plus children in other packages. Means everyone in my home and children outside. That means. Package plus within my inheritance. If the manager is in outside package, he can see me. Because manager is my child. He can see me. So protected, for example, if I say protected employee ID. Okay. Protected employee ID. So this is in this package, right? There is things like edu.wbqa.oop1. Inside that there is a test class. It can't see employee ID. It can see employee, it can create employee object, but it can't do employee ID. It can't get employee ID. It can't get if I make this, it can't see get details. It can create an object, but it can't see my get details. It can't use my get details function. But if I write a manager class there, for example, I wrote the director class there. Director is a child of employee. He can see it. Anyone in this package can see it. Only children from other packages can see it. I mean employee can see it. Means if there is any other class, they can't see it. If you are in other package, you should be child of me. Otherwise you won't get it.